Hello YouTubers, this is what's happening. I'm out here in the garage. This is my water heater for the washing machine, and I've just built and tested the new water heater control. This is just a 3-wire control like the Tech-Luck. I mean, you just slap the thing in there, nothing special. It has arc interruption. Every contact when you break it is going to arc a little bit. But what you want to do is prevent a sustained arc. So here's what else is happening. I got this standpipe I put in, and there's a meter up the top. See, I'm a tall guy. It has to be tall for me to read. And this is a 3/4 inch pipe, and this absorbs some of the shock from the washing machine. And it's really important when you have an off-grid water heater that you have an expansion tank. Otherwise, these pressure relief valves will start to leak. You know, if you ever see one that's weeping a little bit, that's because it got overpressured. Water expands when you heat it up, and in solar applications, you'll be going from a lower temperature to a much higher temperature. And a lot of places have check valves in the water system, and so there's no place for it to go, and it'll shoot out there if people aren't washing their hands and using other hot water. So it's morning, and right now we're at 102.7. You know, that's pretty decent for washing clothes. So here we are, we're at 61.2 volts at 6.45 amps, and we'll switch it over to the old system, and you got about the same voltage and current. So let's look at arc interrupt. This is the wire going right to the water heater, and you'll get a little spark now and then, but you can't sustain it. Whereas if you switch over to the old system, so I think that now I'm back to the new system where it's just a little arc. The camera shows it off a lot better. Must be real sensitive to this. But anyways, I built this. Let's talk about if you actually went to build one of these things. I don't know how just the average person does it really. Here's the problem I've encountered. I put this thing together, and I got just a single FET here, and I did a 110 amp FET, and I put the thing on, and it was like 5 amps, and this thing was pretty warm. And like 5 amps shouldn't do that on a FET that size. And so I took it out and went and tested it. It had 4 times the resistance, 4 times the max resistance of what it should be. And I checked the gate capacitance, and it's like 1/4 of the gate capacitance what it should be. So it's a fake part. I don't mind fakes. If I order a 110 amp part and they send me one that's 95, this is why I parallel a lot of FETs, is because you never know quite what you're going to get, and they're cheap. I go for cheap. And so I pulled out another FET, and that tested the same, and I had a 75 amp, 75N75, which is I used a bunch of them, and that was 3 times the maximum resistance it should have been. This is 75N75 right now, and you know, it's running cool. But that's the problem you have with some of these fake parts, and it seems to be getting worse. So you know, I hate to say get them from good sources, because even then you don't know. But it's worthwhile trying to test one of these. With this I had a 3 ohm resistor that I put in the drain, and I just turned the FET on with 12 volts, and then you measure across from drain to source, see what the voltage is, you know what the current is, and you can figure out the resistance. But you know, the other problem we have with this circuit is that I found, and I don't know what the source was, but I found a couple 2153s that were fake, that when you went to shut them down by shorting the timing capacitor. They went to full output on the low side, so you know that would drive someone who's not experienced crazy. But still, it's fun to learn. Don't let that stop you. And that's why I choose to use multiple FETs in parallel, because then you'll have something that's guaranteed to work. So that's it for now. Again, just a tiny little momentary arc, and woo, don't want any of that. Thanks for watching.